I hope you had some practice making this project network diagrams. So to get any kind of business insight on this, we have to tweak this a little bit. Instead of making just this small circles with just the activity name, we're going to replace each of this with a more informative square. Some people, you'll see some examples, instead of using this squares or rectangles, they still use the circular version of this. It really doesn't make a difference. You need to have at least 7 boxes. That's what is more important. So it's customary to use this top middle one to use the name of the activity. So N is name. So in this case, if we're doing it for A, that would be A. T is the activity time, how long it takes to finish that activity. A would have been 3. ES is earliest start, EF is earliest finish, LS is latest start, EF is latest finish. The meaning of it will be more clear when we do an example. This axis, this is called slacks. We'll describe that as we do the example. I went ahead and took this example we did and converted them such that each of these circles is replaced by one of these boxes. Okay, and I put the activity time. Okay, again, the CPM method, critical path method, it has 2 basic steps. The first is making this project network. Then what we do is what we call forward pass and a backward pass. Let me explain to you what forward pass is first, and then we'll come back and do the backward pass. To get started with the forward pass, we instantaneous all the activities which does not have a predecessor at 0. What that means is you can get started with the activity which does not have a predecessor at time 0. Let me change the color here. We can start those at time 0. Okay, after that we use this rule. The first rule, this is for the forward pass. Forward pass uses rule 1 and rule 2. The rules is very simple. Earliest finish is earliest start plus time. So this is earliest start and this is earliest finish. The left one is earliest start, right one is earliest finish. So earliest finish is earliest start plus time. So 0 plus 3 is 3, 0 plus 5 is 5. Well, the next part of the rule is earliest start is the largest earliest finish, of all immediate predecessors. So for C, it has 2 immediate predecessors, A and B. We take the largest earliest finish. So the earliest finish is 3 and 5. We choose the largest one, 5. That should make sense because remember, this is the earliest start for C. You cannot start C until B is finished. So that is the earliest you can start C is after B is done, that is at 5. That should make sense, right? 5 plus 2 is 7. Again, for Z, it has only one predecessor, so we can just pick this earliest finish and take it here, 7. D has only one predecessor, so you can just pick 7 and 7. Okay, 7 plus 4 is 11, 7 plus 6 is 13, 7 plus 5 is 12. Okay, let's do F. It has only one predecessor, so you can just pick 12. 12 plus 3 is 15. H has 2 predecessors, Z and F, or 3 and D. We take the maximum of it, 11, 13 and 15. So it's 15. 15 plus 3 is 18. I has 2 predecessors, D and F, 13 and 15, which is the maximum, that is 15. 15 plus 4 is 19. J has only one predecessor, so just 18. 18 plus 2 is 20. K has 2, F and I, 19 and 20. So we took the maximum one, 20. 20 and 2 is 22. That's all there is to forward pass. Now to do the backward pass, but before we do the backward pass, let's understand what this 22 signifies. 22 means the earliest you can finish the project. The earliest you can finish the project is in 22 weeks. That is our project completion time. Okay, to do the backward pass, just the way we had to instantaneate the one without the predecessor at 0, the one without the successor, in this case K does not have a successor, so we instantiate them at 22. After that we use the rule number 3. So this is for backward pass. In this backward pass, latest start is latest finish minus T. Latest finish minus T is 20. After that, the latest finish is the minimum latest start of all its immediate successors. So J has one successor, that is K. So you just pick the 20 up here. 20 minus 2 is 18. I has only one immediate successor, so you can just pick this 20 up. 20 minus 4 is 16. Now say H has only one immediate successor, so we can just pick up this 18. 18 minus 3 is 15. Okay. F on the other hand has two immediate successors, H and I. Right? What we do now is we take the minimum latest start of all its immediate successors. So remember, this is the latest start for I and this is the latest start for H. We take the minimum of it, that is 15. That should make sense, right? We have to finish F by 15 so that we can get started on H on 15 and I can get started on 16. Okay, so 15 minus 3 is 12. Again, let's go with E. E has only one immediate successor, so you can just pick up 12. 12 minus 5 is 7. D has two immediate successors, H and I. We take the minimum of it, that is 15. 15 minus 6 is 9. G has only one immediate successor, so we can pick up 15. 15 minus 4 is 11. C has three immediate successors, G, D and E. So we have to take a minimum of it, 7, 9 and 11. The minimum is 7. 7 minus 2 is 5. B has only one immediate successor, so 5. 5 minus 5 is 0. It has only one immediate successor, so 5. 5 minus 3 is 2. That ends our backward pass. After we have finished our backward pass, the next step is to fill up these boxes. And this is what we call slack. Use a different color here. We call that slack. So the slack is the difference between latest finish and earliest finish. That is 5 minus 3 is 2. 2 minus 2 is 2. Again, this should always match. These are same slacks. If you did everything correct, this should always match. So 15 minus 11 is 4. 11 minus 7 is 4. 18 minus 18 is 0. 15 minus 15 is 0. 20 minus 20 is 0. 18 minus 18 is 0. 22 minus 22 is 0. 20 minus 20 is 0. 20 minus 19 is 1. 16 minus 15 is 1. 15 minus 15 is 0. 12 minus 12 is 0. 12 minus 12 is 0. 7 minus 7 is 0. 15 minus 13 is 2. 9 minus 7 is 2. 7 minus 7 is 0. 5 minus 5 is 0. 5 minus 5 is 0. 0 minus 0 is 0. These are what we call slacks. What is the meaning of this? Well, there are two kinds of activities. The activities which have slack 0, like B, and activities which have positive slack. So this has 0 slack, 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 and this has 0 slack. All others have positive slack. This positive slack of 2 means you can be late by 2 weeks in activity A and still finish the project in 22 days. The slack of 0 means there is no slack time. You cannot be delayed at B and still finish in 22 days. If you're late at B, your project completion time will increase. So there is a special path that connects all the activities that have slack 0. So here, this from B to C C to E, E to F, F to H, H to J, J to K. Let me write this here. B to C, C to E, E to F, F to H, S to J, and J to K. We call this our critical path. That means you are late in any of these activities, you cannot finish the project on time. We'll come back and do some analysis, but this is what we learned. We changed our project network from this small circular images to more comprehensive rectangular image. We did a forward pass, which had two rules, rule 1 and rule 2. And we reached to the end, we found out that the project completion time is 22. Then we did a backward pass, and then we, using the difference between the latest finish and earliest finish, and latest start and earliest start, we found slack. We connected a path between all the activities that have zero slack, and we gave it a special name, critical path. We argued we are late in any of these activities, our project cannot be done in 22 days. If we are late by up to the slack time in the activities where there is slack time, we can still finish the project within the project completion time.